ID the Future, a podcast about evolution and intelligent design.
Welcome to ID the Future. I'm your host, Andrew McDiarmid. Today, I'm reading for you an exclusive excerpt from the revised, rewritten, and updated 20th anniversary edition of The Privileged Planet by Dr. Guillermo Gonzalez and Dr. J. Richards. In this provocative book, first published in 2004, Gonzalez and Richards marshal a staggering array of scientific evidence to counter the modern dogma that Earth is nothing more than the winner of a blind cosmic lottery. When The Privileged Planet was first published in 2004, it garnered both praise and rage. But its argument has stood the test of time. In this completely revised 20th anniversary edition, Gonzalez and Richards show how thousands of discoveries of extrasolar planets over the last 2 decades have only strengthened their case. They take readers on a mind-expanding journey through our solar system and beyond. Along the way, they explore the mystery of total solar eclipses, the crucial role of water and carbon, the fine-tuning of physics that makes advanced life possible, and the beginning of cosmic time. From our cozy blue planet to the edge of the known universe, they show how Earth-like planets are exquisitely fit not only to sustain life, but to provide the best platform to discover the hidden wonders of the cosmos. The Privileged Planet compels us to reconsider our place in the universe. Far from a cosmic fluke, our world is ingeniously designed, not just for life, but for discovery. And let me share just one of the endorsements the book has received so far. Simon Conway Morris, paleontologist and author of Life's Solution, Inevitable Humans in a Lonely Universe, says this: "In a book of magnificent sweep and daring, Guillermo Gonzalez and J. Richards drive home the argument that the old cliché of no place like home is eerily true of Earth. Not only that, but if the scientific method were to emerge anywhere, Earth is about as suitable as you can get. Gonzalez and Richards have flung down the gauntlet. Let the debate begin. It's a question that involves us all." Today I'm reading for you the foreword to the 2024 edition, followed by the introduction. Foreword to the 2024 edition of The Privileged Planet. The gratuitous beauty of the starry heavens above, the chimerical appearance of rainbows, the austere splendor of solar eclipses. These inspire people in every time and place. For most of human history, they were also mysteries. In a sense, we've now removed the mysteries. Scientists routinely measure the distances to the stars. We know how sunlight passing through millions of suspended water droplets in the atmosphere renders a rainbow. We can predict to within 1 second the time and place of solar eclipses years in advance anywhere on Earth. Yet these discoveries point to even deeper mysteries. Why is our world, from the local and galactic environments to the constants of physics to the remnant echo of the Big Bang, set up so that we can see the stars, rainbows, and solar eclipses? Being able to see these things per se is not a prerequisite for our existence. Surely the universe could have been otherwise. In 2004, when this book was first published, we connected the dots. We argued not just that the universe is vaguely habitable and open to science, but that those rare places in the universe best suited for complex life and observers are also the best places, overall, for scientific discovery. Moreover, we argued that this is evidence of a conspiracy, rather than a mere coincidence. We set out to test this hypothesis against the best evidence from natural science. We argued that, together, the evidence forms a cumulative case that the universe is designed for discovery. Though we stated the argument precisely, we didn't try to immunize it against future discoveries. On the contrary, we put it at risk. That's why we predicted that relevant new observations, or new analyses of existing observations, would confirm our argument. So, how has our argument fared in the intervening years? Here's a brief survey of what nature has revealed. Nature still speaks. We opened the book by pondering why we can observe perfect solar eclipses. We enjoy them because the sun and moon appear to be the same size from the Earth's surface. While this coincidence has been long known, it still befuddles scholars. 7 years after The Privileged Planet was published, John Gribben observed in Alone in the Universe why our planet is unique. Just now, the moon is about 400 times smaller than the sun, but the sun is 400 times farther away than the moon, so that they look the same size on the sky. At the present moment of cosmic time, during an eclipse, the disk of the moon almost exactly covers the disk of the sun. In the past, the moon would have looked much bigger and would have completely obscured the sun during eclipses. In the future, the moon will look much smaller from Earth, and a ring of sunlight will be visible even during an eclipse. Nobody has been able to think of a reason why intelligent beings capable of noticing this oddity should have evolved on Earth just at the time that the coincidence was there to be noticed. It worries me, but most people seem to accept it as just one of those things. Now, either Gribbon didn't read The Privileged Planet, or he didn't want to admit that he had. Although we explored this topic in detail, we left two issues unresolved. First, while we showed that Earth enjoys solar eclipses far better than the other planets with moons, we didn't consider solar eclipses viewed from other moons. So-called mutual eclipses occur when one moon eclipses another moon in orbit around the same planet, as they do on some outer planets, such as Jupiter, which have many moons. One of us, Guillermo, later studied mutual eclipses in the solar system and found that Earth's solar eclipses are indeed the best. The results of this research were published in 2009. Second, while we explained why the apparent sizes of the Sun and Moon closely match, we didn't explain why they are such a good match. The same year that The Privileged Planet came out, Dave Waltham of the University of London published a paper arguing that the Moon's size is almost too large to stabilize Earth's rotation axis well, within 22 kilometers, about 14 miles. In a later paper, Waltham buttressed the case for the Moon's role in stabilizing Earth's climate. This strengthens our argument. In chapters 2 through 4, we discussed certain ways that Earth is a good platform for scientific discovery. In chapter 3, we argued that Earth's accessible, abundant, and diverse minerals and fossil fuels prepared the way for technology. Robert Hazen, a geologist at Carnegie Institution's Geophysical Laboratory and George Mason University, has quantified just how special Earth's mineral resources are. In his 2012 book, The Story of Earth, The First 4.5 Billion Years, From Stardust to Living Planet, Hazen notes that Earth has the greatest diversity of mineral species of any body in the solar system. Over 4,600 mineral species are known on Earth. Mars only has about 500, and Venus about 1,000. What's more, Hazen discovered that life formed about 2/3 of Earth's mineral species. His work reinforces our argument linking life and scientific discovery. Because our book covered so many topics, it was, in effect, an hors d'oeuvres reception with a dozen small appetizers. Michael Denton's recent books in his Privileged Species series, Firemaker, How Humans Were Designed to Harness Fire and Transform Our Planet, The Wonder of Water, Water's Profound Fitness for Life on Earth and Mankind, and Children of the Light, Astonishing Properties of Sunlight That Make Us Possible, provide a 3-course meal. If our treatment whets your appetite, then we encourage you to check out Denton's trilogy. In Chapter 5, we discussed exoplanets, but only briefly, because at the time just over 100 such planets were known. The number of confirmed exoplanets has doubled about every 27 months since then. As we write this, over 5,500 confirmed exoplanets have been discovered. Some critics, who hadn't read our book, assumed that every new exoplanet discovery would somehow weaken our argument. Our claim, they seemed to think, was that our planet was unique, and therefore designed. That's a clunker of an argument, but it's not the one we made. We didn't know in 2004 if Earth was uniquely habitable. We still don't know that in 2024. For many people, the sheer number of new planet discoveries seems to guarantee many other Earth-like planets in the Milky Way galaxy. But other research in astrobiology rejects this impression. While astrobiologists have been finding exoplanets, they have also been discovering new ways that a planetary system must be fine-tuned to allow for habitable planets. Taken as a whole, astrobiology research in the last 20 years has not changed our view that Earth-like planets are very rare. If anything, that claim is less risky now than it was at the time. We can't yet assign numbers, but we're quite confident that the number of Earth-like planets will be a tiny fraction of the exoplanets we discover, and that any habitable planets we do find will be Earth twins. Turning to the broader cosmos, the theory of general relativity received new confirmations from the first direct measurement of gravity waves in 2015, the first synthetic image of the region around a supermassive black hole in 2019, and the gravitational wave background in 2023. Why do these discoveries matter? Because general relativity is the foundational theory for Big Bang cosmology, which points to a beginning. In Chapter 9, where we covered cosmology, we concluded that we live not just during what we dubbed the cosmic habitable age, which is no surprise, but also during the best time to study cosmology. In a much later, less habitable era, evidence of a beginning and of cosmic expansion would be undetectable. In 2007, we received support for this idea from an unlikely source. Atheist cosmologist Lawrence Krauss, with Vanderbilt cosmologist Robert Scherer, published an award-winning paper on the loss of key information about the cosmos in the distant future. Their concluding paragraphs are worth quoting at length. The remarkable cosmic coincidence that we happen to live at the only time in the history of the universe when the magnitude of dark energy and dark matter densities are comparable has been a source of great current speculation, leading to a resurgence of interest in possible anthropic arguments limiting the value of the vacuum energy. But this coincidence endows our current epoch with another special feature, namely that we can actually infer both the existence of the cosmological expansion and the existence of dark energy. Thus, we live in a very special time in the evolution of the universe, the time at which we can observationally verify that we live in a very special time in the evolution of the universe. Observers, when the universe was an order of magnitude younger, would not have been able to discern any effects of dark energy on the expansion. And observers, when the universe is more than an order of magnitude older, will be hard-pressed to know that they live in an expanding universe at all, or that the expansion is dominated by dark energy. By the time the longest-lived main sequence stars are nearing the end of their lives, for all intents and purposes, the universe will appear static, and all evidence that now forms the basis of our current understanding of cosmology will have disappeared. While it had escaped our notice in 2004, Tony Rothman and George F.R. Ellis had thought in 1987 about alternate worlds where cosmology would go wrong. It is even possible, they wrote in the final sentence of their paper, that universes could exist in which life arises only at times when observations lead to a deceptive understanding of cosmology. These all, in one way or another, support elements of our original argument, which we extended 5 years ago. The Earth, and the broader solar system, is an excellent platform for space travel. Many factors have converged to permit us to put men on the moon and send probes to all the planets in the solar system. Earth contains many crucial chemical rocket propellants, such as hydrogen plus oxygen and water. In contrast, inhabitants on planets only a bit more massive than Earth would have a much harder time getting rockets with large payloads into space. People on planets within the habitable zones of less massive host stars would find it much harder to launch interstellar missions. As it happens, our solar system is in the best place in its 225 million year orbit around the center of the galaxy for interstellar travel to nearby stars. This is just at the moment when such travel has become conceivable. Elon Musk, take note. A needlessly hostile reaction. When we were working on this book at the dawn of the new millennium, we wanted to propose a new hypothesis. We also wanted to add to the growing case for purpose and design in the universe. Our argument hinges on the eerie overlap between the conditions for life and for scientific discovery. Those rare places where observers can exist are, as it happens, the best overall places for discovery. This pattern, we argue, makes much more sense if the universe is designed for discovery than if it is not. So far from being anti-science, our design argument implies that the world is made for scientific discovery. We were perhaps a bit naive about the hostility and metaphysical panic this book would provoke among self-appointed defenders of science and atheist religion professors. These hostile attacks have had serious repercussions for us over the years, but especially for Guillermo, formerly a research and teaching astronomer. While we won't recount these trials and tribulations here, we should note that none of these bad faith attacks have touched our argument or its supporting evidence. On the contrary, confirming evidence has continued to emerge. We're happy to trust fate of our argument to future discoveries and are grateful that this book continues to be read and debated. Introduction to the Privileged Planet. On Christmas Eve, 1968, the Apollo 8 astronauts Frank Borman, James Lovell, and William Anders became the first men to see the far side of the moon. They had been wrested from the Earth's gravity and hurled into space by the massive, barely tested Saturn V rocket. One of their main tasks was to take pictures of the moon in search of future landing sites. The first lunar landing would take place just 7 months later, but a different photograph etched their mission in our collective memories. It's known as Earthrise. Emerging from the moon's far side during their fourth orbit, the astronauts were transfixed by their vision of Earth, a delicate gleaming swirl of blue and white set against the monochromatic, barren lunar horizon. Earth had never looked so small to human eyes, and yet it was never more the center of attention. To mark the timing of the event on Christmas Eve, the crew had decided to read the opening words of Genesis. In the beginning, God created the heavens and the earth. The reading and the reverent silence that followed were telecast to an estimated 1 billion viewers, the largest audience in television history. In his book about the Apollo 8 mission, Robert Zimmerman notes that the spaceman chose those words to include the feelings and beliefs of as many people as possible. Indeed, when most Earthlings look out at the wonders of nature, or Apollo 8's awe-inspiring photo, they see a grand design. But a contrary opinion holds that such a response is emotional, rather than rational, and that our existence is not only mundane, but without purpose. In his book, Pale Blue Dot, the late astronomer Carl Sagan typifies this view. While reflecting on another image of Earth, this one taken by Voyager 1 in 1990 from some 4 billion miles away, Sagan writes, "Because of the reflection of sunlight, Earth seems to be sitting in a beam of light, as if there were some special significance to this small world. But it's just an accident of geometry and optics. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves." But what if this melancholy belief, despite its heroic pretense, is wrong? What if the scientific knowledge gained in the last century, when rightly interpreted, bespeaks a purpose behind our place in the cosmos? What if, when viewing Earthrise, an overwhelming sense of awe and gratitude turns out to be the reasonable response? In the following pages, we hope to justify that response by means of a striking feature of the natural world, one as widely grounded in the evidence of nature as it is wide-ranging in its meaning. Simply stated, the conditions that allow for intelligent life on Earth also make our planet strangely well suited for discovering the universe. The fact that our atmosphere is clear, that our moon is just the right size and distance from Earth, and that its gravity stabilizes Earth's rotation, that Earth's geology records and preserves events about its past, that our place in our galaxy is just so, that our sun is its precise mass and composition, all of these and many more features are needed to make Earth habitable. But they also have been crucial for scientists to measure and discover the universe at both the smallest and largest scales. Mankind is oddly well placed to decipher the cosmos. Scrutinize our world with the best tools of modern science, and you'll find that a place with the right ingredients for intelligent life will also afford that life a clear view of the universe. Such so-called habitable zones are rare in the universe, and most of these may be devoid of life. But if there is another civilization out there, it will also enjoy a clear vantage point for searching the cosmos, and maybe even for finding us. To put our argument both more generally and more technically, discoverability, including what we call measurability, correlates with habitability. Is this correlation just a coincidence? Are we just lucky? We think not least because this evidence contradicts a popular idea called the Copernican principle, or principle of mediocrity. This principle is far more than the observation that the cosmos doesn't literally revolve around Earth. It's a metaphysical claim. The argument goes like this. Modern science, since Copernicus, has moved human beings ever farther from the center of the cosmos. As a result, scientists should assume that our place, literally and metaphysically, is unexceptional. This principle is often paired with what philosophers call materialism, the view that the material world is all that is, or ever was, or ever will be, as Carl Sagan famously put it. Following this principle, most scientists have supposed that since the universe is vast and ancient, our planetary system must be typical, and the emergence of life quite likely. Thus, most have assumed that the universe is teeming with life. In the early 1960s, for instance, astronomer Frank Drake proposed what became known as the Drake equation. With it, he sought to list the factors needed to detect chatty ETs. The factors range from the rate at which stars form to the likely age of civilizations prone to sending signals to strangers on other planets. 10 years after he proposed it, Drake's colleague Carl Sagan used the equation to conjecture that our Milky Way galaxy alone might contain as many as 1 million candidates. Probability theorist Amir Azel is similarly sanguine about the possibility of ETIs, as his book title reveals. Probability 1: Why there must be intelligent life in the universe. This optimism finds its practical form in the Search for Extraterrestrial Intelligence, or SETI, a project that scans the skies for radio signatures of ETIs. SETI seeks evidence that would prove that ETIs exist. In contrast, some advocates of ETIs are content to rely on math and best guess estimates of the various factors in the Drake equation. We were weaned on Star Trek and other science fiction and wish it were that simple. But such certainty is misplaced. Mounting evidence suggests that animal life needs just the right setting, and that the chance of getting all the right details at the same place and time is remote. A few scientists have begun to face these facts. For instance, in 1998, Australian planetary scientist Stuart Ross Taylor stressed the rare chance events that formed our planetary system, with Earth nestled in its narrow habitable zone. He argued that we should not assume that other planetary systems are like ours. Similarly, in Rare Earth, Why Complex Life is Uncommon in the Universe, paleontologist Peter Ward and astronomer Donald Brownlee focused on the many happenstances that joined forces to give complex life a chance on Earth. These views challenge the Copernican principle, but while violating its letter, Taylor, Ward, and Brownlee followed its spirit. They assumed, for instance, that the origin of life is more or less a matter of getting liquid water in one place for a few million years. As a result, they still expected simple microbial life to be common in the universe. And they all keep with the philosophy behind the Copernican principle. "We're just incredibly lucky," Peter Ward remarked after the release of Rare Earth. "Somebody had to win the big lottery, and we were it." But there's a better explanation. To see this, we must connect these recent insights about habitability, the prerequisites for complex life, with discoverability. Discoverability refers to those features of the universe and our location in it, both in space and time, that allow us to detect, observe, uncover, and determine the size, age, history, laws, and other properties of the physical universe. Discoverability is what makes natural science possible. Crucial to discoverability is measurability. Although scientists don't often discuss it, the degree to which one can measure the wider universe, and not just our local neighborhood, is surprising. Most scientists assume that the world can be measured. Read any book on the history of science, and you'll find plucky tales of ingenuity, grit, and dumb luck. What you likely won't see is any mention of the countless fortuitous features of nature and our place in it that were needed for such feats. We think this eerie overlap between the needs of complex life and scientific discovery suggests not coincidence, but conspiracy. However, our argument is subtle. First, we don't argue that every aspect of discovery is individually optimized on Earth's surface. Nor are we saying that it's always easy to measure and make discoveries. Our claim is that our earthly perch allows a stunning diversity of discoveries, including a diversity of measurements across the sciences, across the universe, and at every relevant size scale. Yes, there are places that could be better for measuring this or that feature of nature. But repeatedly, we find that if we were in one of those places, the cost for doing other kinds of science would greatly exceed the benefit. For instance, intergalactic space might be a better spot to study certain distant objects than the surface of any planet with an atmosphere and a host star. But intergalactic space would be a terrible place for learning about the recent past, the structure of stars or how they form, and the laws of celestial mechanics. Likewise, a planet in a giant molecular cloud in a spiral arm might be a great perch to study how stars form, but it would hide the distant universe. Earth, in contrast, strikes a winning balance. It offers great views of the distant and nearby universe while providing a special platform for discovering the laws of physics. When we say that habitable places are optimal for science, we're referring to an optimal balance of competing conditions. Engineer and historian Henry Petrosky calls this constrained optimization. All design involves conflicting objectives and hence compromise, he explains in his book Invention by Design. And the best designs will always be those that come up with the best compromise. Think of the laptop computer. Engineers design laptops that strike the best compromise among various competing features. Users might prefer large screens and keyboards, all things being equal to small ones. But in a laptop, all things aren't equal. The engineer must account for trade-offs among such matters as CPU speed, hard drive size, peripherals, weight, screen resolution, cost, aesthetics, durability, ease of production, and the like. The best design will be the best compromise. Similarly, to make discoveries in fields from geology to cosmology, an environment must balance trade-offs. The best place for science will be one that meets or exceeds a host of thresholds for discovery. For instance, there's a threshold for detecting the cosmic background radiation that was left over from the Big Bang. To discover and measure something, you must be able to detect it. If our atmosphere or solar system blocked this radiation, or if we lived in the future when it has disappeared, we couldn't discover and measure the stunning confirmation of the Big Bang. Now, the space between galaxies might give us a slightly better view of the cosmic background radiation, but we would be cut off from everything that can't be measured from deep space, such as the information-rich layering processes on a terrestrial planet. The best setting for scientific discovery, then, will be one that meets many diverse thresholds needed for fruitful discovery. In this sense, our local environment is optimal for science. The cosmos, our solar system, and our exceptional planet are themselves a laboratory, and Earth is the best bench in the lab. Even more mysterious, the features of our home that provide the best overall setting to discover the world around us are the same rare properties that allow for our existence. This is the correlation between life and discovery. It's a surprise we had no right to expect. We don't believe this is mere coincidence. It cries out for another explanation, one that suggests there's more to the world than many have been willing to entertain. That was a reading of the new 2024 Foreword and the introduction to the 20th anniversary edition of The Privileged Planet, published by Gateway Editions. You can learn more about the book and order your copy at privilegedplanet.com. That's privilegedplanet.com. For ID the Future, I'm Andrew McDiarmid. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.